Alright, this video is going to be on graphing rational functions, which an example is given here of that blue graph that is on the grid down in the corner. You'll notice that this is a type of hyperbola, but instead of opening vertically or horizontally, this one actually opens diagonally. So it's like you've taken a hyperbola and rotated it 45 degrees. An important thing to know about all rational functions is that their parent function is the function y equals 1 over x, which is actually the graph that I just showed you on the first slide, was a graph of y equals 1 over x. Now we can modify this in various ways and transform it using the transformations that we've learned in class or that you've maybe seen in some of my other videos. And those transformations, again, are translations, dilations, rotations, and reflections. And we're going to go over how to do all of those in this video. The way we're going to look at that is by using the equation y equals k plus a divided by x minus h. And this equation will give us all rational functions. We can write any rational function in this form. The h and k are our center point, and then a is the dilation scale. Right? And so if we're given that information, we can just plug it into this equation. If we're given an equation, we can find that information. Alright, so let's say we have the equation y equals 3 plus 4 over x minus 2. The first thing we're going to do is we're going to figure out what our center point is. Our center point is h comma k, and if you remember, the h is this value down here, and k is this value here. The important thing to remember is that the original equation says x minus h, so since there's a minus there, when we have x minus 2, h is actually a positive 2. And then k does not switch its sign because it was a positive k in the original equation, and so since it's still a positive number here, it'll stay positive. Alright, so not sure if you guys heard that phone go off, but let's get back to the problem. Sorry about that. So the center point is again at 2 comma 3, and then we need to just look at our a value, which in this case is 4, which is coming from right up here. Alright, now, the nice thing about this is it has vertical asymptotes instead of diagonal asymptotes like a hyperbola. And the way we're going to draw those asymptotes is just look at the x and y values of our center point. So since x is at 2, we're going to go over to the line x equals 2, and that's going to be a vertical asymptote. So that's right here. So you can just dot in that line. So this isn't part of the graph. It's just the asymptote for the graph, which again, asymptotes are lines that the graph approaches but doesn't actually touch. And then for the horizontal asymptote, we're going to look at the y value. And since the y value of the center point is 3, we're going to draw a vertical asymptote, horizontal asymptote at the line y equals 3, which is right there. And there we have our two asymptotes. And you'll notice that the center point, 2, 3, is the point directly where those two cross. Now, where a comes into account is what we're going to do is we're going to get 4 points that are actually on this rational functions graph. And the way we're going to do it is we're going to go to our center point, so right here at the center point, and we're going to go over 1. It's always 1, so we go 1 to the right, and then we're going to go up 4 units since a is 4. So 1, 2, 3, 4, and we're going to put a point right there. Right? And then we're going to do the same thing now again, but we're going to go up 1, and then over 4, and put a point, oops, that's at 3. I did too much. Alright, so there's our first one, and up 1 over 4 gives us the second point. Now we're going to do the same thing going back 4 and down, or back back 4 and down 1 to get the point right there, and then left 1 and down 4 to get the point right there. So those 4 points are actually on our hyperbola, or rational function graph. And then what we do is we're going to draw a curve that goes through those points and approaches the asymptotes. It shouldn't touch your asymptotes though. We put arrows on the end of these because they keep going on forever and ever and ever. Right, so there's the graph of the equation y equals 3 plus 4 divided by the quantity of x minus 2. Alright, so let's go ahead and let's do another example. Let's say that y equals 5 minus 3 divided by the quantity of x plus 2. So in this case, our center point is going to be at 5. I'm sorry, not at 5. 5 is going to be the k value. And then h comes from this plus 2. But remember the original equation, we said x minus h. So if we have a plus 2 here, that actually means that we're subtracting a negative 2. So h is negative 2. And in this case, a is coming from this 3 up here. But since we have minus 3 right here, we have this subtraction sign, a is actually a negative 3. So now if we're going to go ahead and graph this. So the first thing I'm going to do is I'm going to graph my vertical and horizontal asymptotes. I'll start by graphing the vertical asymptote, which is at x equals negative 2. So it's going to go right here. And then my horizontal asymptote is at the line y equals 5. And I'm getting those numbers from the center point. So I have that. And then to graph my a value, I'm going to go over 1, but now instead of going up 3, I'm going to go down 3, and so I'll have a point right there. And then I'm going to go down 1 and over 3, so I have that point right there. And then same thing, I'm going to go left 3, up 1, and then back 1, up 3. Oops. Sorry about that. There we go. Alright, and then again we just draw on the curve so that it's passing through both of those points and approaching the asymptotes but not touching them. Alright, and there's our hyperbola. If you have any questions, please feel free to email me or get in touch with me in some way. I'll put a practice problem on here so that you guys can try one on your own. And good luck. Alright, so here are 3 equations that you could try graphing yourself as practice. The second one is probably going to give you the most trouble because of this 1 up here for A. But I'll let you guys struggle with that. If you have questions, like I said, feel free to email me. So there's your practice problems.